So this is Chem 130. This is like the lecture class. It's kind of strange because if you've taken anatomy and physiology, it's one class and it's lecture and lab combined. But here, lecture and lab are actually two separate classes. So if you're in Chem 130, that's just this class and you'll get a grade for this. But then you had to sign up for Chem 130A. So Chem 130A, you take one of each. Chem 130A is the lab course. Here, if you grab one of those. So Chem 138, if you are a nursing student or if you are in vet tech, you need Chem 130A. There is a night Chem 130A lab that meets on Wednesdays, or you could do the online class. So what you need if you're going to take the Chem 130A lab class, that's all you need from the bookstore. You don't need a kit or anything else if you're in the on-campus face-to-face class. It's a $10 lab handout, okay? So that's it. That's all that you'll need for the entire semester. Now, if you take the online class, so you have to buy a kit that gets shipped to your house, and you do labs at home, and you have like graduated cylinders and little hot plates and balances and all kinds of stuff you do along with it. But if you're in the on-campus, the face-to-face, all you'll need to do is make sure you get that at the bookstore, and it's $10. The book is this book. Okay, so this is by Pearson. It's their general organic and biochemistry text. It's like made to really be a one semester class versus some of the 2 semester books. You don't have to have the physical book. There is the list right there. So it's by Frost and Deal. It's a 2020 edition. You can actually get it from the bookstore. You're really just going to get an access code. Has anybody gotten theirs already? It's really just like a booklet. And when you open it up, you see a code. Okay, so that's where you're going to use that code in Moodle to be able to access all of the textbook publisher material that you'll need for the entire semester. And it was what, like $110, $120, something like that. Okay, so we used to sell the book and the access, and it was like $250. So it's like we've kind of like pared it down, even with the lab manual, trying to like, I wrote the lab manual, so that's like, because it's self-published now, that made it even cheaper compared to buying something bound. So we've been trying to get things under cost control. It's really been a challenge, but that's all that you're going to need for this class. If you want a loose leaf book, like if you're a person that really likes to have the paper, you can actually order it. I'll show you, there's a link in Moodle that you could actually order one to have shipped to your house directly from the publisher. You could also go on a website like Chegg and just rent it for the semester. Usually that's like $30, and you just have to ship it back to them. And so there are a couple of online textbook rental places that you could use if you decided you really wanted a physical textbook. Okay? All right. So this class, being the lecture class, we're going to start at 5:30 and we'll go till 6:45 on Mondays and Wednesdays. We're always being here for this portion. I'm Holly Carmichael. I have been teaching, this is 28 years that I have been teaching. Yeah, 95 is when I started teaching. It seems a little like outrageous to me that I'm finishing up 28 years of teaching, but it's come a long way. I really enjoy it. I'll tell you, lab, like doing the hands-on stuff is my favorite part, but I really like chemistry. I'm a biochemist, so that's what my master's degree is, in biochemistry. My office is kind of like upstairs in this front corner. Okay, it's 7239, but I'm not usually in there. If I have class, I'm in class. If I'm in lab, I'm in lab. In the in-between times, I do have some office hours. So you see Mondays, so from 2 to 5 before this class, I have office hours. And then Wednesdays from 3 to 4 before your night class, in between the lab and a night class, I have office hours. But I'm in 7213. That is what we call the STIL, which is the Science and Technology Learning Lab. And it's actually like upstairs, but kind of in the middle of the hallway. It's kind of a small room that used to have a lot of computers in it. So now we actually have student tutors. So there is a student chemistry tutor. She is a student that has taken 3 semesters of chemistry. She's had general organic, 2 semesters of general, 1 semester of organic. She's in her 2nd semester of organic. She's really, really good. And so she's an option. Other chemistry instructors have their office hours, and I will actually post those in Moodle when I know everybody's schedule. I just don't know what her hours are this semester, but I will have that posted in Moodle. But I'm in there for Mondays and Wednesdays, so you can send me an email, you can just drop by, it doesn't really matter. I don't have any formal sign-up times for it. I do have virtual office hours on Thursday from 11 to 12, and so if you needed to to see me, I'm around then anyways. I'm on campus. It's for my online students, so that's sort of their dedicated time. Okay? So going down through, so that's sort of the information here. Second page on this gray syllabus. Second page is super important because this tells you where your grade comes from in this class. So I learned early on that giving a lot of chapters on per exam set people up for, it's just so much information. I can't keep track of it all. And so I have like gradually given more and more tests over my teaching experience and fewer chapters. So if you notice, like exam 1 or test 1, it's only over chapters 1 and 2. 3 and 4 is test 2, okay? Because that's like the math basis is all of chapter 1, unit conversion, significant figures, and students really kind of struggle getting that hard and concrete. So that's why we spend more time on that. Chapters 3 and 4 is bonding and then organic chemistry naming, and students struggle with that. So that's why those are just 2 chapter tests. Once we get into 5 is like chemical reactions, more theory, less math. Carbohydrates, more theory, less math. So there it's like 2.5 chapters, 2.5 chapters. Test 4 is a take-home exam. So once we cover that information, I will give you your test. You have an entire week to work on it before you turn it back in. Okay, so like that should be an A. And all the questions come from lecture material. So it's not like stuff that you would have no idea. It's all material that we'll be covering in class. So 4 usually ends up being an improvement in terms of a grade booster. Test 5 is over usually 10 and 11, sometimes some of 9, depends on how much we get through in chapter 9 for test 4. It just sort of depends how far along we are. So there's 5 of them. I dropped the lowest, okay? So if you're going along, so say like you bombed test 3, okay? Something happened, you just didn't study and you bombed test 3. That's not a problem because one of them gets dropped. So I'm only going to count the top 4 grades. But I will tell you it's really nice if you do well on the first 4 and you don't have to take the 5th, right? Because then you can be like, oh, I don't really have to study for the 5th one because I've got, 80s and 90s on all my other exams. So that's a big plus. So kind of keep that in your head, especially, once Easter and all of the spring break stuff all rolls around. That's when we're really looking at exam 5 and then coming into the final. The final exam is cumulative, and it's not a true cumulative open questions. I'll actually give you a page that tells you the topic of every single question on the final, okay? So that you'll know, you won't know the question, but you'll know what the question topic is. And so that's like there's 40 questions. So you have like 40 topics that you just have to go back over in order to make sure that you're good for that. Okay, so that ends up being 79. 21% of your grade is what you do in the online assignments. So you have 2 different assignments that you've got due in the Mastering Chemistry. You've got assignments that are due based on the material we're covering in class. And then you also have material that's due before we cover the chapter. So the pre-lecture questions, those are really only designed to take you maybe half an hour to do. They're pretty basic kinds of questions. They're not like super complicated questions. But what it does is it gets you to look at the chapter, to look at some of the topics, so that when you come in, it's not like brand new. You'll be like, oh, I saw that on the pre-lecture question. So I kind of understood it, but now hopefully we're going to like completely go over it so that you're completely understanding it when you walk out of class, so that then you can do the after lecture assignments and you're like, okay, that makes sense. This makes sense. Like hopefully you'll find that this is building and it's really a challenge. Chapters 1 and 2, or really chapter 1, really try to make sure that you get all of the steps, processes, practicing the math in chapter 1, because you're going to see it again and again and again throughout the semester, okay? Because it's math, right? So math, you've got to practice in order to make sure you get it. But we'll work through things as we go, okay? So that's where your grading comes from. One last thing to note. So do note, see that it says that you must complete 80% for full credit. So what that means is at the end of the semester, if your total grades for the chapter assignments is at least an 80%, I just change it to 100, okay, at the end of the semester. So if you miss a couple of questions, don't like fret about it. Don't be like, oh my God, it's going to pull my grade down. As long as at the end of the semester you have at least an 80 in the pre-lecture and the chapter assignments, then you should be fine. So exams, I've got exams, they're already scheduled. You typically will take an exam on a Tuesday, or sorry, for you guys, it's a Monday night. I'm always thinking about my Tuesday, Thursday class. So you'll take it on a Monday night, and I'll get them graded, and I'll actually give them back to you to look at on Wednesday. So I'm not one that holds on to exams. I'm not one that like waits to do the grading. I know you want to know how you did, and if I let things back up, I'll never get things graded. So like I'm kind of one that as soon as something comes in, I try to get it graded because I know that there's more things coming in all the time. So you do want to make sure that when I'll give them back to you to kind of review them, check them over, see what you got wrong. Maybe you will learn like, okay, why did I make that mistake? So that can help you in terms of being a better test taker and alleviate some of the anxiety that sometimes students have about taking tests. So there's information here about the mastering. If you haven't bought the access code, you can buy it from the bookstore. You can buy it directly from the publisher. So if you're paying for this out of pocket, you could actually buy it directly from the publisher. But you do have a 2-week free trial. So let me show you really quick where those are set up. So in here, so here's your Chem 130 class. So in here, there's the book. There's my office hours, my email. That's always the best way to get in touch with me. So there's your Mastering Chemistry link right here. Okay, so it'll be all the way up to the top. There's the e-text link. So if you want to just go to the e-text directly and go through any of those, the link for that is right there. And if you wanted to get a loose leaf, the printed loose leaf, that one, I'm trying to remember. I think it was 50. Last time that I remember checking, if it's going to work for me. Yeah, so it's 54. Just, okay. So it's like, so if you decided, okay, like I really want to have the paper version, so it's like 54, and then you buy it, it's yours to keep. It's a loose leaf version, but like I said, you could also check some of those textbook rental places to see if it's any cheaper, but that's what it looks like. So it's a 4th edition, and it's got the pineapple on the front. That's really the one that you want to, if you did rent it, you would want to have. Okay, so when you go into the assignments, it's going to look a little different to you because you're a student, and so I'm, as an instructor, like I end up seeing a whole lot of diagnostic kind of stuff. But if you pull it up, yours is going to look a lot like this. You can look at it in 2 ways. This is the list, and you won't have the options of availability. It'll just show you when your due dates are for things. But you can also look at it under a calendar, and I'm kind of a calendar. I like this because I like being able to look at the calendar and see, oh, this is due on Friday. This is due on Saturday. Okay, you can kind of see them. So I would suggest like make sure every week you're checking on mastering to see, okay, what's due. So you'll see that I don't have things like all due at one time. You have, when we cover information, and this first one, this is like a tutorial how mastering works, I guess, is kind of a tutorial one. That's the Friday one. You don't get a grade for that. It's just a tutorial. But chapter 1, the pre-lecture assignment, normally you would have to have that done by the time you came into class, but you wouldn't have known that because we're just starting. So I'll give you until Saturday night to do the pre-lecture. So chapter 1 pre-lecture, it's open for you until Saturday night. Then you see that you've got a couple of dynamic study modules that are due. So the dynamic study modules ask you the similar questions multiple times to see if you understand. Guessing on those, I wouldn't do that. I would actually check your notes when you get a problem, check your notes to answer them so that you move through it a little bit quicker. If you finish or complete the dynamic study modules, those are all the orangey looking ones. The pre-lecture ones are always going to be in purple. Then those points automatically go into your grade book. So you'll have that. I'll put it up higher, but it'll actually show up here. See where you have Mastering Chemistry scores. So once you complete an assignment, it'll start showing up in your total scores. You can see your running average. I do have like a little tutorial overview. If you have any problems, do make sure that you use Chrome or Firefox. New versions of Safari are okay. Don't use Edge, don't use Explorer. Those, just because of their extensions, they don't always work with some of the images that are in the Pearson Mastering Chemistry. So just make sure that you're always, Chrome is really the one that works the best even with Moodle, but you can use Firefox, and new Safari is okay too. I did do a couple of tutorials for some of the ones where you have to do a chem draw, because that always throws people too. They're not, it's just a matter of making sure you go through and do things in a certain order. It's kind of the way to get those. Okay, so those go in, just pre-lecture questions are due before. Do I have 9 a.m.? I thought I changed all those. So that one should be 5 p.m. So it'll close on 5 p.m. the day that we start that material. Dynamic study modules are typically going to be due on a Sunday after we've covered material. And you'll see, make sure that you check that little mastering calendar in the link in Moodle, and that way you're sure. The last one that you've got is you've got what they call post-lecture homeworks. So these are due before the exam. Post-lecture homeworks that are designed to take you about an hour per chapter. And again, these will close on 5 p.m. on the day that we have an exam. So I have to go back and make sure I change that. It's not 9 a.m., it'd be 5 p.m. is when it would change. These, you have 3 chances to answer each of these questions. Okay, so it's not just like a one and done kind of thing. And in fact, many of them have hints. Some of them will give you feedback. So if your answer is wrong, it'll give you feedback about what you need to do to make sure that you change that answer and get it right. So those are kind of the things to do. 21% of your grade is based on those. Now, I will say with course communication, please sync your school email with your Gmail. You know, you can do that on your phone. So you can sync, if you go to Gmail, you can add an account. You can add your school email as a Gmail-based account. So you can put in your first, middle, initial, last name, last 3 digits of your student ID at st.nashcc.edu. That's a Gmail account. So if you do that, like if any announcements come in, that's an easy way to like, oh, let me just check, okay? You can ignore all the PR stuff and everything else, but especially like trying to make sure that you get a reminder, you get announcements, and that means you don't have to like have your tablet with you. You don't have to like be sitting in front of your computer to be able to check your email. Really try to check your email at least twice a week, okay? I will tell you that I check my email in the morning when I'm drinking coffee. I check it in noontime in between my classes, usually in the afternoon or evening, and then typically at night before I go to bed, okay? So if you have a question, feel free to send me an email, okay? Because you're gonna get a response much faster than if you tried to call me and leave me a voicemail. I think my voicemail says, please don't leave me a voicemail. Just because I'm not in my office very long. Attendance, so I will check you off each time that you come in. If you come in a little late, if you think I might have missed you, just let me know. So I think I've got, are you Letitia or Aaliyah? Aaliyah. Okay. All right, so we just missed one. Okay, but just know that we have attendance. If you miss more than 2 weeks worth of classes, then you're not considered attending in any of your classes. And so that requires that I actually have to drop you. I have a maximum absence limit of 15%. And so that would be 5 classes. So if you miss more than 15% of the course of the in-person classes, then the odds are is that you're not going to pass the class. And so it's really like better if you drop this class and focus on your remaining classes to try and make sure that you pass classes with an A or a B versus like getting D's and having to repeat things. So I don't, as we go along through the semester, we may end up having discussions about that. And I mean, I know sometimes things come into play, and I've had students have to go from a seated face-to-face class to an online class or switch from one to the other. I'm totally willing to work with you. Just let me know, okay, if anything goes on. I do encourage you, like, pull this syllabus is posted in Moodle, so it's actually the very first thing. If you go up to the Moodle page at the very top, there's your Chem 130 syllabus. So like if you click that link in there, you've got all of these links. That Nash Community College resources is a huge potential help for you. I encourage you to go through it. This can give you information about scholarships, about like gas money, about like we have a food pantry, we have a clothes closet, like for people going on job interviews. There is a lot of resources that Nash has, and a great deal of them are listed here. We have like a student wellness center now, which is actually staffed by like a counselor. So somebody that's got like a master's in social work. So if there is an issue, a problem, and you're not sure where to go, this is a good place to start. And if you ever need like a referral or anything, just say, all you have to do is tell me I need a referral to the Swell. Okay. Like I have no problems. I don't need to know anything. All you need to do is just tell me what you need. Okay? Because I want to try and get you to where you need to be. I don't want anything that's going on that's you're struggling with trying to get something under under a manageable level. I don't want that to be the reason that you're not able to be successful in this class. Okay, so I just encourage you to look at it. I think I actually put this link too. Yeah, so if you look here, there's another link to that same resource page that I think you would find, like, it's really amazing some of the things that the school, even in the last 5 years, has kind of like built and decided to make a focus on. Last page, well, not the last page, but the next to the last page, okay? This is the page, like, I'm like, if you do nothing else, I would say, like, fold your paper and have it handy in this page, because this tells you when everything is due all semester, okay? So this tells you when exams are. This tells you what our topics are in each class. This also tells you what dates mastering and chemistry assignments are due. So notice in this, like this coming Saturday, that pre-lecture for Chapter 1 is due, and then on Sunday, the dynamic study module for understanding matter is due. So it gives you all of those days. Like I told a couple of students before everybody was here, Monday, just make sure you have a note. Next Monday, it's Martin Luther King Day, so we don't have classes. That's our holiday. And then we do not have a break until April. Okay? So we have class every Monday and Wednesday until April. So April the 10th through the 14th is that spring break. It's an entire week that we have off. And by then, you'll have turned in your take-home exam, rolling into exam 5 and the final. So when you come back, we literally have 3 weeks of school and we're done. So it's always like, that's what I say, this is like, you have this long February and March. At least April's a little early. I've had April as late as like last year. It was really late. It was like 25th or something like that. It seemed like it was nothing. By the time we came back, we were done classes. Okay, so everything that's due, notice that you have things due. If it's a dynamic study module, it's going to be due on a Sunday. Pre-lectures are due on Monday or Wednesday. It's just always going to be due on the day that we're going to start that chapter. Okay, now all of these are already open, all of your assignments. I just went ahead and opened all of them, but the pre-lecture, the post-lecture homeworks, these assignments like close. Okay, so that's where keeping track of the little calendar, making sure that you get things done, and as you finish them, they'll actually like disappear. Okay, so then you're like, oh, I don't see them, but if you look in your mastering scores, if you look in the scores, you'll be able to see them. So that way you'll know, okay, I've got everything done. Okay, so 2 things. So one, on your, you picked up the little blue card. If you would, fold your card in half and just put your name on the front of it. Just put your name on the front so that as you stand it up, then that way I can kind of see. It just sort of helps me. I'm really bad with names. You would think after this long that I'd be really good with it. No, still terrible. In fact, I see students like a semester after I've had them, I'm like, hey. Terrible names. So bad. Okay? So if you would just kind of keep this for the next week or 2. But one thing I want you to do, just because I think it's a good thing to always try to keep in mind. So on the front, you just put your name, whatever you want me to call you. And if your name, your first name is not what you go by, do let me know, because I'll just change it in my grade book so that I can keep track of who you are. But on the back, I want you to write, like, what is your motivator? What is your motivator to be in this class? Okay, so like what's going to be like a motivator to keep you here? So like make you do your dynamic study module on Sunday when you're like, oh. Okay, what's going to be something? Some people it's like money. Okay, well, you know, everybody has to eat, you know. But for some people, maybe there's a family member, something that's happened, and it doesn't have to be anything that you have to share with me, but I'm saying if you put it on the back, you see it. And so that's kind of the plus. I see your name, but you're seeing what is your reason? What's this like the motivator for you to like go, okay, I'm going to spend the time, I'm going to learn this, or I'm going to spend the time, I'm going to do this extra worksheet, I'm going to practice this. You can take a second and think about that maybe. So in a class this small, this is never as interesting, but let's see how many people actually have any of these characteristics. So does anybody here have a 4-year degree? Okay, so other than me, all right. Has anybody ever eaten snails? Escargot? No? Okay, I have. Okay, how many people have played a sport in high school? What'd you play? Volleyball. All right. Yeah, I played basketball, like, of course. How many of them, not well, but I did play. How many people can play a musical instrument? What'd you play? Guitar?
Tenor saxophone.
Tenor saxophone. Is that the big one? Mm-hmm. Very cool. Guitar. All right. Nope, I'm like musically inept. Okay. Have you ever been to an outdoor music concert? Which kind? Where?
A lot. Country music mostly.
Okay, country music.
A lot. Country music.
Country music.
Rap and hip hop.
Really? What's like the most interesting? Anyone that I would know of?
Lil Wayne.
Yeah. Uh-huh. Yeah, I know who Lil Wayne is. What have you?
Was R&B, and I went to a Her concert in Virginia Beach.
Oh, very neat. Yes, and so I have heard of that one too. Yes, I'm a big Dave Matthews Band fan. Like I've been to like 12 Dave Matthews Band concerts. Mm-hmm. I used to drag my children. Come on, we're going. Right. Right. Mm-hmm. Dave Matthews, I would say, kind of like, I don't know, adult, contemporary. I don't know. He's just kind of like, sort of laid back.
He's
Not,
very laid back.
yeah, just kind of laid back music. No, yeah. It's been a while since I've been to any heavy metal, headbanging, screaming kind of concerts. Yeah. When I was very young, it's been quite a while. Can anybody speak a foreign language? I can't either. No. Anybody sing? Like we have some people that work here on the campus that have like amazing voices, and I am like, no. Nobody? No singers? Oh, okay. Have anybody fainted? Anybody ever fainted in public? You have? That's embarrassing. I haven't. I've had students in A&P. They had to do blood draws, and I've had 2 students hit the floor. Biggest thing, if you ever have to do your A&P 2 lab, eat. You have to make sure that you eat before, because both of them, they just got as gray, and they're like, it was like, grab them, they're going down. And that was it. Both of them admitted, I didn't eat anything before. Yeah, that's a big one. Is anybody scared of spiders?
As long as I can see it, I'm cool with it.
Yeah, I'm about the same. Snakes, too. I'm fine with snakes as long as I can see them before. But, like, if you come around a corner and there's, like, something right there, yeah, then I'm done. Nope, no. Yeah, I win the prize for stitches. So in February, I tripped and fell and tore a ligament and had to have surgery in April. And then in November, I was walking down the hall upstairs, did not even fall, and just ruptured a tendon in the same foot. So now I have 2. And I had about 28 stitches in this last one. This is like ugly. I was like, I have like Frankenstein-like now. So I win that one. Like, no doubt. Yep, so I have, like I said, I've been teaching for 28 years. I have 2 children, 2 daughters. One is 33 and she lives in Massachusetts. The other one is 30 and she lives in California. Yeah, I know. They like both were like, okay, bye. Yep, just left me at home with 3 dogs. So it works out just fine. And they call and I talk to them all the time. But that's, yeah. One's married. She's expecting. I'm going to be a grandmother in May. Yeah, so lots of excitement. Yeah, I just have to get the one in Massachusetts. Yeah, neither of them are really here. They're both pretty. One is like close to Boston, and yeah, the other one's close to Sacramento. But yeah, so that'll be an interesting one for me. I do encourage you, like whether you do it when you come in or if you take like when we get done tonight, I really encourage you to get like the names, emails, and things like that of other members in the class. Because, if you have a question about something or if you're just not sure about something, sometimes it's more familiar to message somebody. You may want to ask somebody, like, if you've got, in lab. How many people are in lab on Wednesday night? So 1, 2, 3, 4, 5. Okay, so Amber, make sure that you, like, get other people's. Because, like, that way, basically we finish in here Wednesday and you all just trudge upstairs and we have lab 15 minutes later. So we just go straight up. So you'll find like that you start to kind of get to know people a lot in lab because there's some downtime where you're sort of sitting waiting for a reaction to finish, and so you sort of start to learn people. But I really do encourage you, either as a study partner or even just having somebody that you're like, did you do this? What did you think they do? What did you get for that? How did you find this? Sometimes having just another person explain something really can make a difference. So do try to connect with other students that are in your class. Okay? So one of the things that I have found, and it's entirely up to you, one of the things that I have found that does help is being a little more active in taking notes. So, we didn't have PowerPoints when I first started teaching. I had like a chalk and a board. And so I would just like write everything on the board, and I was always coated in chalk. Like I was all yellow, dusty looking. But that students really had to write down. And so there was so much of this writing, but sometimes it seemed like they were writing so much that they weren't learning. They were just trying to copy down absolutely everything that was said. So one of the things that PowerPoint actually, I think, is an improvement is that PowerPoint will let you, if it does it, PowerPoint will let you add notes to things. And so that's how I've really developed these slides. So these slides, you have some information on the slide, but you don't have everything. And so this way, you can go through and directly add. So I printed out the first chapter's worth of PowerPoint slides, and I didn't print them one slide per page because that's an awful lot of paper to end up using. But what I did is I did them the three slides, and then you see you've got some white lines. So what you can do is you can add your notes directly to these. So you can add your notes into the slide spacing itself, but then you've got that extra room to be able to add the notes. And so printing is free for the first week of the semester. So if you have a chance, on Wednesday, if you can get here at 5, you can go over and print a couple of chapters. All of the chapters are in, I don't know if it does it. It does do it. They gave me a new computer, and I'm like, I don't know what it does. Okay, so here are all the PowerPoints. So there's all the PowerPoints for the entire semester. I don't know why chapter 6 is up there, but all of them are there. They're all out of order. I'll get them all straight. But if you just click them, download them, and then when you go to PowerPoint, you go to print and choose the handout, and you can do 6 per page, or you could do the 3 with the lines, print them front and back like this one is. And they usually have gotten all of my PowerPoints, so they're somewhere between 40 and 50 slides. I've been paring them down. So that way it's if you divide that by 3, so it's somewhere around 12 to 14 pages, but it's on front and back, so then it's only about 6 to 8 pages. So it's not too many pages, but this is a way of trying to kind of keep it organized. I've seen some students that write just on regular paper, but then if you don't bring that notebook, then everything starts getting out of order. Or if you have other pages, I've 3-hole punched these ones, so if you have a binder, you could slide it into a binder and just have it as an option. So that's one of the things that I gave you is already done. The other one, you see the laminated, so the laminated periodic table, that I will always have out, and you can just grab one when you come into class, but just don't take that home with you. So when you leave, make sure that you put it back. So that way, you've always got it. And when you take your exam, you'll have it as well. So I have it right there, but I also made it in this little handout. We're going to actually use these next time. So we have the unit conversions page, then we got a balancing equations page, and then that third page, here's the periodic table, okay? So we're going to talk about this very first thing next time. And so this one you could write on, add notes, shade things in, to help it kind of stick in your head. But when you come to take your exam, you'll always get this, okay? And that's on the wall, okay? So you do not have to memorize a periodic table. You really just need to figure out what is it telling you. Because there's a lot of information in the periodic table. You don't have to memorize how many protons, neutrons, and electrons. You just have to know how to use the periodic table to figure it out, okay? So you can see different rows and different columns have different characteristics. So we'll go over that, but that'll be one for you to use. When you take an exam, every exam you will get, before the exam, one of these. It's a 4x6 piece of paper, and you can write any notes that you want. I call it your cheat sheet. You can write any notes that you want on one side for every exam. So exam 1, you can write whatever you want from chapters 1 and 2 on your note card. So I would also encourage, as you're like going through and doing your PowerPoints and stuff, going back, looking at it, things that you're like, I'm not sure if I'm going to be able to remember that, like highlight that stuff, because that stuff that then you want to put on your note card, so that when you go back and you're like, you'll have this, bring it with you to take your exam, and you can use it. Always also have, you'll always get a calculator. Okay, so I don't know if you have a fancy graphing calculator or if you have something that's like this. So this is just a TI-30. It's like a $10 calculator at Walmart. That's all that you need in terms of a calculator. If you have a graphing calculator, fine, I will show you how to use it. But if you don't, I will always have these with me. I have about a dozen of them. So I always bring them with me to class, especially if we're doing any kind of math. But I always find it's difficult if you're borrowing mine. How are you practicing this at home? So I would really encourage you to, if you don't have one, it's a $10 Walmart calculator. All it has to have is if it has log. If you see it has log function on it, log, exp, sine, cosine. Really the only thing we use is log. We use exponents, and then that'll be enough. I'll show you how to use it, but I really want you to be able to like practice. That's a big thing too. I want you to be able to practice it as well. Any questions?
I see like a chapter 12 short version.
Yeah, because usually when we get to chapter 12, that's the very last chapter, and we only usually have one lecture. So like I gotta cover metabolism in one lecture, which is an hour and 15 minutes. That's why it's the short version. Because normally it would take at least 2 lectures, but we typically only end up spending 1 lecture on it. So that's why I have kind of like pared it down to, okay, you eat carbohydrates, this is what happens. Okay, you eat proteins, this is what happens. Okay, you know, like just like kind of like a real quick overview of metabolism is kind of chapter 12's. Okay, all right, so those are all in there. So if you kind of like this tonight, like the setup of the PowerPoints, I really encourage you to try and get over to the library and get them, go ahead and print them out. You can print out the entire semester if you have, you know, because you've already paid for it. That's what they go, it's free. It's not free. You had like a student activity fee that has been like, was chunked into your tuition. Well, that's your printing. Okay, so you've already paid for the benefit of being able to print. So if you find the PowerPoints printed like this or having that physical, then go ahead and get those done. I do have like I write on mine, and I have some students who'll come, they have like writable tablets and they take their notes directly there on the PowerPoints as we go. That's fine too. Doesn't matter to me. Like I always tell students, they're trying to give you absolutely everything I can think of to help you learn, right? So if you learn by writing, you learn by kind of doing. If you have to work things out, then these really do help, because when you write something down, you're seeing it, and you're seeing in the mechanical part of writing really helps. I also am recording this lecture, so you can see it's like being recorded, and I actually post these on YouTube. So if for some reason you miss a class, you can actually sit down, and I'll usually have it posted the night of our lecture. It takes about an hour to process, but I post the link to it in Moodle, so you could actually go back and listen and watch it, so that it's not something that's just, I missed class, so I have no idea what they talked about, but you could actually go back and watch it. Okay, so I've got that, and then I also post my marked up PowerPoint. So if you think you missed something on the PowerPoint, you can actually pull up my marked up PowerPoint and be able to see what I wrote, so that maybe that'll help you in like, oh yeah, that's what it was. And so then you can make sure you have like all of your notes completed when you go to study. So you learn by hearing things, seeing things, and doing things. And so I've tried to kind of work out, hey, go ahead and take one of each. I've tried to really work out ways for you to do all of them, okay? And you've really got to figure out how you learn best, right? So that's like 3 pages. Some people can, like I had friends in college that could actually they had photographic memories. So they could think of almost like flip pages of notes in their head and see it was on this page over in this corner, and they could no, that wasn't me. I couldn't do that. But that's it was, so school was really easy for them because they could do that. So they could just retain pages of information. I had to write it. So writing things down, seeing it in my own handwriting, that's where it started to finally stick in my head. It just took me until I was a junior in college till I figured it out. Okay, so I'm just telling you now, like, take my advice. Like 30 years ago, I figured out how to study. And so it has kind of changed. I mean, so much of the technology has changed, but really it's still like trying to figure out how to organize it in your head so it makes sense. So it doesn't seem just like this jumble of information. Okay, so first off, in chapter 1, they just talk about sort of what I call like some old school definitions. So chemistry. So what is chemistry? Chemistry is a science, okay, just like biology, just like physics. So anything that's a science, it's a systematic study. It's the study of what do you think? When you think of stuff, when you think of chemistry, elements, chemicals, okay, all of those fall into the category of matter. It's the study of matter and all of the changes that happens to matter. So that's those chemical reactions, how molecules, particles interact. So that's its definition. So then that leads to the next definition is, okay, well, what's matter? Matter has two characteristics. Does anybody remember that from high school? Matter is anything that has space. Takes up space. What's the first part? Matter is anything that has mass. Sometimes those like definitions come back and you're like, oh yeah. Anything that has mass and takes up space. Okay, so when you think of mass, we think of like weight. Okay, so we think of the heaviness or the amount of a substance, and then space is really volume. So solids, liquids, and gases, these are different states of matter. So you can have the same substance, like water is the easiest example, right? So water as a solid, that's ice, right? But water can also flow like a liquid. But if you boil water, you can make steam, which is the gas. So we can have water in all those states. But the molecules of water interact differently. Which one are the particles the closest? So solids, if we stick like, we'll just put like 12 little dots. If I had 12 little dots in a solid, they're going to be really closely packed. So solids, like your desk, they are going to have a defined amount of shape. They don't just change shape randomly. And what about volume? Do solids change their volume? No. Right? So shape and volume are going to stay the same, kind of constant or defined. How do you think liquids look? If we're going to take 12 dots and do a liquid, are they going to be closer together or further apart? A little, not a lot. They still touch each other, but there's enough space so they can slide around each other, which is why liquids have the ability to flow. So we're going to make our dots just a little more spaced. I'm going to try and keep track of them. There's 9, 10, 11, 12. But now this dot can slide. This dot can move. They're not stuck in one position. So what's that going to do to their shape? Are they in a, they can change shape. So we're going to have a variable shape. They're going to take the shape of their container. But what about volume? If you have a cup of water and you spill it on the floor, is it still a cup of water? Does it have the same volume or does the volume change? Same volume. So it's still going to have a defined or definite. Go back. So the volume's still the same. It looks a lot more when you spill it on the floor. than it is when it's in a cup. It's just because it spreads out into a thin layer. Now what about gases though? If I took 12 dots to do gases, where would I put them? Everywhere, right? They'd be really far apart. In fact, gases act as if no other molecules are around. They almost never come in contact with each other. There. Okay, very far apart. So what would you say about their shape? Definitely variable. Variable shape and volume. So gases will actually take the space of whatever their container is, and they will take up the volume of whatever that container is. Okay, so then the last thing. So in terms of vibrational activity, so these molecules don't just stop. You have to get them really, really, really cold to make them stop. So they vibrate, okay? So which ones do you think vibrate the most, solids, liquids, or gases? So think about vibration. The more they vibrate, the more space they need. So it would be gases, right? So vibrational activity, that is really like their active or kinetic energy. The more they vibrate, the more space they need. So gases have the highest kinetic energy, the highest activation or the highest vibrational activity. In order to get them to become a liquid, you got to chill them, right? And then they slow down, and then they become a pool of liquid. So this one's in the medium. But in order to take a liquid and make it into a solid, I'm going to have to take that energy away. So those molecules are vibrating so slowly, I can pack them in. Because once they start vibrating, they're going to start bouncing against each other and forcing themselves apart. So the solids are going to have the lowest. So just some differences in solids versus liquids and gases. And water is kind of unique because you can find water as a solid, a liquid, and a gas on Earth. And very few molecules exist that way. Like carbon dioxide is always a gas. The only way you can make it into a solid is if you make dry ice. That's solid CO2. Okay? So really, really cold temperatures to get it down to that. All right, now. Next. Some days. I have a new pen. There. New pen. Yay. All right. So then the next question. Okay. So if matter is things that have mass, take up space, if they are solids, liquids, and gases, like what is not matter? What in this room is not a solid, a liquid, or a gas? The desks are solid. My water is a liquid. The air is a gas. But what is going on in this room maybe that doesn't involve a solid, a liquid, or a gas? It is, so it would be energy. So energy is another one. Energy has another definition. Energy is the ability to do what? This is one word. Okay, movement is an example. That's mechanical. The lights would be what? Electrical. The sun would be solar. Thermal, if you have the heat, right? If you turn the heat on. 2 mornings ago, I got up, I was like, I don't think I turned the heat up last night. It was like 62 in the house. The dogs were like, oh my God, she's trying to kill us. I get underneath the covers, like, we're not coming out. All this, I always think of energy as being like this action, right? So like when you think of things moving, you think of the lights being on, about the sun shining, about heat exchange that occurs. It's the ability to do work. So it's really kind of an action. Whereas I always think of matter as being like a noun, right? It's a thing. It's like the desk, the air, the liquid. So it's more tangible. So I always think about this as being like a verb. So we can have energy that's in motion, right? So when we talked about that kinetic energy that solids, liquids versus gases have, when we think about things that are kinetic energy is the measure of the amount of active energy. What work is it doing? So what's potential? How can you have potential energy? Okay, if something's still, right? So instead of moving, like laying on the couch, okay, that would be an example of potential mechanical energy. We could move, but we're not going to move. I have one of my dogs is a pug, and she lives by that. Like her goal, like I will get up because I hear the food bowls are being put on the counter. I better go see what's going on. But then she's like, and now I'm getting on the couch. Wake me up if there's snacks. Like, I'm fine. She is like the ultimate potential energy, right? So they think of it as being stored or inactive. I always think of potential energy. It could do work, but it's not doing it right now. Like these lights, okay? So these lights have potential energy. They're not on. All I have to do is complete the electric circuit by flipping the light switch. Okay, so once I complete the circuit, then electricity flows and then the filaments will glow. But if I stop that, they still have the ability to light, unless they blow out. They still have the ability to glow, but I have to do something to change that. So like a candy bar is an example of chemical energy. If it's on the shelf, is it doing work? Is it providing energy? No. What do you have to do? Yeah. Okay. So if it's in its wrapper, that's potential energy. There are carbohydrates, fats, proteins in that candy bar that you can utilize to run your cellular processes. But unless you eat it, then that's not going to happen. Okay. So things like that would be good examples of potential or stored inactive forms of energy. And that example really does show you that energy changes form, right? So ultimately, they say all energy comes from the sun, right? So the sun shines, and it shines on the wheat in the fields, and then, so what do those plants do? Yeah, they're green. They collect that sunlight. And then along come the animals. So here comes the cow or the sheep, the deer, whatever. So animals then, they eat these plants. And so the chemical energy that the plant used to grow, now the animal is going to ingest that plant material, break it down, and utilize the energy. So when we form chemical bonds or break chemical bonds, that's a way of being able to transfer energy from one form to the next. So as the animal eats, he grows, but he also releases heat, right? So like if you feel your face, you're a little warm, right? So you're always like releasing radiant heat energy to the area around you. So the animal's like kind of using this energy in lots of different ways. So we could then take and transfer this and transfer that. So we could talk about how this energy is basically transferred from one thing to another to another. It would just keep on going. So when we talk in chapter 5, we'll talk about chemical reactions, and we'll talk a lot more about energy, talk a little bit about energy in the next chapter when we do radioactivity. So those are some basic definitions. So I said that matter, it has mass and takes up space. So it's got mass and volume. But then we can take and we can classify matter into two characteristics or two categories. We're going to either say matter is either going to be a pure substance or it's going to be a mixture. And most of the time, people are much more familiar with the mixture. Like when you cook, you're making a mixture, okay? If you make a cake, it's a mixture, right? Because you've got cake mix, you've got eggs, you've got oil, you've got water, and you blend it all up, okay? If you make a milkshake, it's a mixture because you have milk and you also have ice cream. Put it in, add your toppings, whatever, blend it all up. You've made this mixture. So things aren't chemically combined. Mixtures are when things are physically combined. So it's two or more substances that are physically combined. And in theory, we could separate them. It gets kind of hard sometimes to separate them. But the theory is if they're physically combined, you could separate them. It's much more challenging to separate a homogeneous mixture. Why? What does a homogeneous mixture look like? If you see something that's homogenized or it's homogeneous, how is it going to look? The same, right? I think of milk, right? So you buy homogenized milk at the grocery store, okay? So the word homo means same. So it looks the same. So it might be a little more challenging, and you may need to know a little more information about the substance to figure out if it's actually a mixture or a pure substance, because it might look the same, but it's still two or more substances physically combined. Heterogeneous, though, hetero, how are these going to look? Different. So this one's always easier to pick out and go, oh, that's heterogeneous mixture, because you can see parts, pieces, layers. It'll separate to some degree. So if this has separate parts, layers, then it's pretty easy to pick that out. In fact, then you're like, oh, I could pick out these pieces, I could separate them, and I could have smaller components that look the same. So the examples that I'll give you will pretty much be examples that we'll have talked about, the ones that you'll see on your exams and such. It'll be ones where you'll get some information about it so that you'll have some idea. Or it might be something that you would just have experience with. For example, coffee, okay? So if you think you go to Dunkin' Donuts and you're like, I go on a coffee with cream and sugar. They give you that coffee. Is that a pure substance or a mixture? It's a mixture, right? Because you know that they put milk and sugar in there. So there's two things that went in there. Plus you have the coffee. And coffee itself is a mixture because you start off with the beans that you grind and you put hot water through them and this brown liquid comes out. So clearly that is not the exact same as what you started with. So we just got some stuff out of those coffee grounds. And you know there's caffeine, flavors, and all of that in it. So it may look homogeneous, but you know it's a mixture because in your head you can deduce, okay, well, I know how it was made. And so those will be a lot of the ones that we'll do as examples. So it won't be one that you're like, I don't know, we never talked about that. Okay? I'll try to give you ones that we've talked about so it won't be so odd. The other class or category, though, are ones where you can't separate them physically. Pure substances, the small units of a pure substance, if I take a pure substance and I split it in half, it's still the same stuff. If I split that in half, still the same stuff. I could actually go all the way down to individual units, still the same. The only difference between these two elements are all made of the same atoms. The smallest building blocks of matter, elements, you will identify because they're on the periodic table. Okay? So that makes that a little bit easier. So you don't have to memorize those ones. There's a certain number you'll need to know. You don't have to know all of them. But if it's on the periodic table by itself, like carbon, then you can look at that and go, oh, C, carbons on the periodic table. I know that's a pure substance. I know that's an element. Compounds are made of 2 or more atoms, but they're chemically combined. So they're not physically, I can't physically separate these. And there is a fixed ratio. So for example, H2O. So you know that as water. So H2O, it is if you have nothing but H2O in a container, that is a pure substance. And if I took that and I separated, if I went all the way down to the individual molecules of water, they would all be the same. They would all have the same characteristics. That would be considered a pure substance. It's a compound because it has H, which is, and O, which is oxygen. And you can find H and O on the periodic table. So if you see them written, they call that a formula. So if you saw something just like C, okay, then you know that's an element. Okay, so if you had like N, or if it just said nitrogen gas, you would know that that's an element because nitrogen's the N. But if you see something that has a formula and there's more than one element in a ratio, then you know that that is a compound. So H2O, NaCl, okay, that's sodium chloride, table salt. You could even be talking about ones that are bigger, like glucose, C6H12O6. So I know that there's 6 carbons, 12 hydrogens, and 6 oxygen in 1 unit of that sugar. So it's that fixed ratio. So that's what the chemical formula tells you. So just remember the number after the letter tells you how many of that letter there is. So H2O would be 2 hydrogens and 1 oxygen. Notice they don't put a 1. If there's a 1, they leave it off. Okay? So you won't, NaCl means 1 sodium and 1 chlorine. Okay, that they're in a fixed ratio that way. Okay, so just those same definitions of ones that you would see. Mixtures versus pure substances, homogeneous and heterogeneous mixtures, being able to pick those out, and then pure substances are either going to be an element or a compound. So one thing to remember with this, like if you're given any substance, you can identify it first as a mixture or a pure substance. So if you look at a substance, it's either an M or a PC or PS, right? Mixture or pure substance. But now if it's a mixture, then you define it as homogeneous or heterogeneous. If it's a pure substance, you define it as an element or a compound. Even though a sample of water is going to look homogeneous, you don't call pure substances homogeneous or heterogeneous. Okay? So mixtures get defined. So you're going to take a mixture and you're going to define it either as a homogeneous or a heterogeneous mixture. You'll take a pure substance and then further define it as an element or a compound. So much fun. Okay. So Gatorade. Okay. So like I said, some of these will be ones that, okay, like you've seen this. So this isn't something brand new. So what would you say Gatorade is? Is it a pure substance or a mixture? It's a mixture. And so if you've looked, you can see that it's got things like water, coloring, flavoring, sugar. Okay, it's got salts in it, all those things. So you know those things are all put together. That's a mixture. They're just physically combined. So is it homogeneous or heterogeneous? Okay, so if it's a mixture, then you define it as homogeneous or heterogeneous. So what about chocolate ice cream? It's a mixture. It's not an element. Right? So you know it's like ice cream is sugar and cream. Chocolate. Cocoa would be in this one. Okay? So then what? Homogeneous or heterogeneous? Yeah. But now if it's chocolate chip ice cream, that one's going to be a mixture, but it's hetero, right? Because it's going to have little black pieces. And theoretically, you could pull all those little black pieces and separate it. So they're both mixtures, but it's how they visibly look. Now, what about distilled water? So I will tell you, distilled water, you take water, it gets boiled into a steam, it goes into a tube where it's cooled, and it condenses back into a liquid. So it's different than tap water. Tap water has any kind of salts and elements, metal, whatever might be in the water, chlorine and everything else. That's also in your tap water. But distilled water, they actually take a sample of tap water, boil it, collect just the steam and condense it. And none of that other stuff comes. It's nothing but pure water. So what is that? That's a pure substance. And you look at it, it won't have any stuff floating in it. It won't be cloudy. Not like the Flint, Michigan water. Okay? Like Spring Hope. Anybody live in Spring Hope? They've been having like boil water alerts like over the last 4 weeks, like 2 or 3 times. Don't drink your water. You better boil it. I'm like, geez, they got to get themselves. So no, distilled water is not that. So this would be a what? It's a pure substance. And if it's a pure substance, you're going to classify that as? So if it's an element, you would have H2O up there as a single thing. So it's a compound. Okay, so this is a compound because it is H2O, and it's nothing but H2O. Whereas tap water, so I said tap water can have water, chlorine, some salts, even some metals in low concentrations, microbes. So what would that be? That's going to be a mixture. And in theory, it should be, I would hope not. Sometimes in August, Wilson water sometimes looked a little heterogeneous, like there'd be like floating stuff in it. And you're like, plus the smell, I used to be like, oh no. So in theory, it should look homogeneous. People feel better drinking water that doesn't look like there's stuff floating in it, but there might be times you want a water filtration system. Okay, so I'm going to give you a couple, and then we got to quit because and like you're supposed to like remind me at 6:45. We're here from 5:30 to 6:45. I'm not supposed to do this till 7. But this is a good way to sort of practice because in this first column, I want you to put either pure substance or mixture. And then over in the second column, if it's a pure substance, tell me if it's an element or compound. If it's a mixture, tell me if it's homogeneous or heterogeneous. So you'll identify it this way or that way. That makes sense? First line, pure substance or mixture. Second line, further define element or compound if it's a pure substance, or homogeneous, heterogeneous if it's a mixture. Just put down your thoughts. All right, so we're going to do the first 4, and then we'll do the second 4 next time, like to kind of pick it up. So what do you think for NaCl? Pure substance or mixture? Pure substance. Okay, and then if it's a pure substance, is it an element or a compound? Compound, because you see Na and you see Cl. So since you see 2 different elements. Now the next one may require some description. So 10 karat gold. So what does carat mean? So you can have 10 karat gold, you can have 14 karat gold. The highest karat gold you can have is 24 karat. What does that tell you? Anybody know? Nope, doesn't tell you how big it is. Those are carats. Those are diamonds. Bigger is better. It is a mixture because gold, if you had pure gold, you could just bend it. You couldn't make jewelry out of it because it would just bend and fall. It's really soft. A solid gold bar, you can bend it. So they add stuff to it. So you add zinc to it. You add copper to it. And so the more metal you add to it, the lower the carat. So that's 24 karat is really the highest gold content and still is firm. You can still use it as jewelry. If you get any higher than that, it's too flimsy. So 10 karat means that it's a mixture. And so that's not one you would necessarily know. So if I was going to ask you this one, I'd have to give you more details. I'd give you a story. Okay? But when you look at 10 karat gold, is it uniform or can you see layers, parts? Can you tell the copper from the zinc? It looks uniform, right? So it's homogeneous. So notice if it's a mixture, it's homo or hetero. If it's a pure substance, it's an element or a compound. So what about salt water? And? Okay, so if you took water and you put salt in it and stirred it up, what would happen? It would dissolve. So would you be able to see any layers, parts, or pieces? So normal conditions, it'd be homogeneous. I mean, you could make it saturated and end up with stuff, but mostly it would end up this way. So oxygen gas, right? So like people have O2 tanks. So if you have a tank of oxygen, it's a pure substance. And that would be a not compound because it's O2. So it's just one. So that is an element. Okay, so you can look at these other ones. Some of them, like you may not know, we'll have to talk about them as well. But let's go to the next one. The last thing to give you is to get you more familiar and comfortable with the periodic table. This is the chart that's in your book, okay? It's also in, I actually copied this and put it in Moodle as well. It says like periodic table from the text that gives you the differences in colors. So to help you get more familiar with the names and the symbols for elements, here are the ones that you need to know, okay? So it's a total of 30. There actually is now 118 elements. You don't have to learn all 118 names and symbols, just these 30. First off, elements 1 through 20, okay? So by number, see the number above each of the symbols in the block, and you've got a periodic table. You've also got one you can write on as well. So 1 through 20, they going across 1 and 2, hydrogen and helium. Then 3 and 4, lithium and beryllium. 5, 6, 7, 8, 9, 10. B is boron, C is carbon, N is nitrogen, O is oxygen, F is fluorine, and then Ne is neon. So that's that second row. So that goes to 10. Then the third row across, you want to know these names and symbols. So Na is sodium. That one's a weird one because sodium is not SO. It's Na. Magnesium is Mg. Al is aluminum. Si is silicon. P is phosphorus, which is one that people commonly mistake. They say potassium, okay, because it's a P. So that's one that's like they're sort of a challenge sometimes. S is sulfur, not sodium. Cl is chlorine. Ar is argon. And then 19 and 20, K is potassium, and Ca is calcium. So elements 1 through 20, you want to learn their names and symbols. Then I got 10 more, and the reason why I have these other 10 are these are ones that we are going to talk about over the course of the semester. So you are going to see, and they're actually in order going across. So if you go across, do you see number 24? That's chromium, Cr. Then 2 further down, Fe, that one is iron. 1 over Co, number 27 is cobalt. Cu is copper. Zn is zinc. Then going all the way almost to the far end, Br, that's bromine. So Ag, Au, and Hg are kind of, well, if you look underneath copper, AG is 47, that's silver. AU is 79, and that's gold. And then right next to it, number 80, that's mercury, HG. Okay, so then the last one, iodine, because I ran out of room. So iodine's over in that upper corner, and that's just I. So I'll give you, if you want to go back, like I told you all, this one's in the PowerPoint. You've got it all printed there as well. But if you wanted to look back at the color one, I said that I have my marked up ones that I post on Moodle. But another place that you can always look, keep those, if you go to your e-text, I'm not quick because I know I'm already running over. If you'll pull it up, if you go to your e-text, going through chapters, so like there's chapter 1, so like the e-text like splits it up into, you can like read different sections as you go through. So I know like the periodic table, so here you're going to find the periodic table, here it is right there, and it's going to give you more information as well. But like a lot of these, you're going to find that there are appendixes at the very end. I want it to be down here, down, table of contents. Oh, and they call it this. It's called back matter. We used to always have it listed as an appendix. So if you click on back matter, all the way down at the very end of chapter 12, like they have things like, here is the periodic table again, but then on the next page, here is the list of all of the elements with their names and symbols. Okay, so if you like, oh, I want to go back and I got to look some of those ones up and check the spelling on them. Like if you want to double check phosphorus, how to spell phosphorus, so you can find them. It tells you what the name is and what their symbol is, and then tells you what element number they are, what their atomic number is. Okay, but that's in this place that's called back matter. So the way that you get there is you just go to the very end of the table of contents. They don't call it appendixes anymore. But see, so they have useful resources. There's some unit conversion resources. There's some gas law equations. But that's really the one place like for looking up names and symbols of the elements that would be an easy place to be able to go and find. Okay, so next time we will kind of like talk a little more about the periodic table. So like I said, there's a paper periodic table. So this one that you've got here, this one you'll always get when you come to take an exam. But I did have one printed on the back. So you've got a paper one. So if you want to like color this, or if you want to write on this, like make notes on this, just to help you become more familiar. I like this one because it's got the zigzag lines real prominent, but you always have that one up there as well. Okay, and those are the ones that we'll use. So make sure that you bring all of this back with you. Do leave your periodic table when you on your way out. Keep everything else. And like I said, if you have found that these are like taking notes this way seems to be okay, I really encourage you to go ahead and get them printed for the. This one has, I think this is just chapter 1 though. I don't think I printed chapter 2, so you would need to go and download chapter 2. Yeah, it's just chapter 1 stuff. So you'd want to download chapter 2 and go ahead and print that out. Okay?